good day, my dear grade 7 students. So how are you today? I'm hoping that all of you are doing fine and safe at home. So for today, in Mathematics 7, we're going to discuss about polygons and convexity. Before we proceed into our discussion, let us have first our opening prayer. Let's bow our heads and feel the presence of our Lord. Lord, help us to listen with open minds and hearts as we begin our mind, body, and spirit retreat today. Help us to learn something new today. Guide us, Lord, to learn the skills necessary to build healthy relationships with our families and friends as we follow your Son, Jesus. Amen.
Our previous discussion, we have discussed about parallel lines, wherein when we say parallel lines, so these are lines on the same plane that do not intersect. Then the transversal is the line that intersects two lines on the plane at different points. Of course, we also discussed about the corresponding angles. So remember that when we say corresponding angles, so they are congruent. Then the alternate interior angles are also congruent, the same as with alternate exterior angles are also congruent. Then when we say same side interior angles and same side exterior angles, they are supplementary. Okay? So remember that different properties that we have already discussed in the past lesson.
So at the end of the lesson, you can illustrate polygons such as convexity, angles, and sides. And you can derive inductively the relationship of exterior and interior angles of a convex polygon. I have these figures wherein you would notice that I have here triangle with 3 sides, 4 sides as square, 5 sides as pentagon, hexagon with 6 sides, heptagon with 7 sides, octagon with 8 sides, nonagon with 9 sides, decagon with 10 sides, and undecagon with 11 sides. So these are what do we call as polygon. So when we say polygon, it is a closed figure connected by line segments and satisfies the following conditions, wherein you have each vertex belongs to 2 segments only, and no 3 or more vertices are collinear. You would notice in this figure. So let us first recall that the parts of polygons such as sides, vertices, and angles. They could be consecutive or non-consecutive. So when we say non-consecutive vertices, they may be connected, called diagonal of the polygon. So let us use this example 1, wherein we are going to check the parts from the given figure, wherein we have DFHON, or polygon DFHON, wherein you are going to find for these consecutive sides. So in this given figure, it is said that the consecutive sides like line segment DF and line segment FH, and there are many other pairs. Then non-consecutive sides such that line segment DF and line segment HO. Then we have consecutive vertices such that point D and point F. Okay? Then the non-consecutive vertices such that point D and point H. Okay? Then the consecutive angles such that we have angle D and angle F. And the non-consecutive angles such that we have angle D and angle H. Then the diagonal are what we call as the line segment DO. So these are some of the answer when you are finding for the consecutive sides, non-consecutive sides, consecutive vertices, and of course we have the non-consecutive vertices, consecutive angles, and non-consecutive angles, and of course diagonal. In this example, we can find another consecutive sides such that we have the line segment NO and line segment OH. Then we have the non-consecutive sides such that we have line segment NO and line segment FH. Then the consecutive vertices such that we have point N and point O, or vertex N and vertex O. Then the non-consecutive vertices such that we have the vertex N and the vertex H. The consecutive angles such that we have angle N and angle O. The non-consecutive angles such that we have angle N and angle H. Then of course the diagonal such that we have the diagonal or the line segment FN. Triangles and quadrilaterals, other polygons, are named using consecutive vertices. In naming a polygon with 5 or more sides, we prefix the word polygon to set of consecutive vertices like polygon faces and polygon alike. A polygon with 6 sides is named as polygon normal. So in this given figures, it is said that we have here the convex polygon, the not convex, or what we call as the concave polygons. Then we have the not polygons. Then we have here not closed, segments crossing, not all sides are segments not on one plane. So it is said, class, that we have here a convex polygon wherein it is said that in a convex polygon, the amount of space or region inside the polygon is maximized. In our entire discussion, the word polygon would be taken as a convex polygon. So as you would notice in this given example, so we have different kinds of polygons, okay? This exercise wherein you need to use protractor to measure all the interior angles of the triangle in a figure 6. So in figure 6, we have here the triangle ABC. So what will be the measure of triangle A or angle A? So it is said that we have here 60 degrees. Then the measure of your angle B is also 60 degrees. The same as with the measure of your angle C, which is also 60 degrees. And if you add the measures of angle A and the measure of angle B, plus the measure of angle C, so we have here 180 degrees. Because according to property 6, it is said that the sum, the measure of the interior angles of a triangle is equals into 180 degrees. Remember that, class? You remember, class, that it is said that in property 7 that the sum of the measures of the interior angles of a quadrilateral is equals into 360 degrees. Okay? Then, of course, let us extend the use of these properties to the sum of measures of the interior angles of the other polygons. First, let us have the property 8, wherein the sum of the measures of the angles of a polygon is equals into the quantity of n minus 2 to be multiplied by 180 degrees, where n is the number of sides. Okay? Then, of course, you will notice in this given figure or in this table that we have here the polygon, the number of sides, the number of triangles, and the sum of their angles. So, if your polygon is triangle, so with 3 sides, the number of triangle is 1, and of course, the sum of their angle is 180 degrees. Then, you have here the polygon quadrilateral with 4 sides, then 2 triangles with 360 degrees as the sum of their angles. Then, the pentagon with number of sides such that 5. Then, we have 3 triangles. Then 540 degrees as the sum of the angles. The hexagon with 6 sides, 4 triangles, and 720 degrees, the sum of the angles. And then heptagon with 7 sides such that we have 5 triangles and 900 degrees as the sum of their angles. Let us use this example number 2 wherein it is said that 5 angles of hexagon are 156 degrees, 87 degrees, 100 degrees, 95 degrees, and 118 degrees. Now, you are asked to find for the 6th angle or the measure of the 6th angle. So, of course, let us find first for the sum of the angles using n minus 2 or the quantity of n minus 2 times 180 degrees wherein n is the number of sides. So, we all know that when we say hexagon, we have here a polygon with 6 sides. So, 6 minus 2 multiplied by 180 degrees. So, you have 4 times 180 degrees. So, such that we have 720 degrees as the sum of the angles. Then, let's find for the measures of the 6th angle wherein we're going to have 720 degrees to be, then minus the sum between the 5 measures of the angle, so such that we have 156 degrees plus 87 degrees plus 100 degrees plus 95 degrees plus 118 degrees. And that would become 556 degrees, so 720 degrees minus 556 degrees, so we have 164 degrees. Therefore, the sum or the measure of the 6th angle is 164 degrees. In the previous discussions of angle of a triangle, angles of a quadrilateral, and angles of any polygon, the angles referred to are interior angles. In addition to the interior angles of a polygon, we also have exterior angles of the polygon. So it is said that the exterior angle of a polygon is an angle that forms a linear pair with an interior angle of the polygon. So this figure shows an interior and of course exterior angle of a polygon. So recall also that the linear pair angles are adjacent angles whose non-common sides are opposite rays. Then of course remember, class, that we have here the property 9 wherein it is stated that an interior angle of a polygon and its corresponding exterior angle are supplementary. So let's use this given example wherein we have to find for the value of x and the measures of the interior angle and its corresponding exterior angle of the given polygon. So in this given example, so this will be the figure. As you would notice, we have here 7x minus 25 plus 5x plus 1 is equals into 180 degrees. Then let us combine all the similar terms. So we have 12x because we have 7x and 5x, so 12x. Then negative 25 and positive 1, so we have negative 24 by the rule of sign is equals into 180. Then use the addition property of equality. So we have 12x equals into 204. Then we have here to divide 12. So we have x equals into 17. So therefore, the value of your x is 17. Now let's find for the measure of the interior angle, wherein your interior angle measures 7x minus 25 degrees. So you have to substitute for the given specific value. So you have 7 times the value of your x is 17 minus 25.
Then 7 times 17, that is 119 minus 25. So therefore, the measure of your interior angle is 94 degrees. And then the measure of your exterior angle, wherein you have 5x plus 1. So just substitute 17 to your x. So you have 5 times 17 plus 1. So 5 times 17, you have here 85. Plus 1 is 86. So therefore, the measure of exterior angle is 86. So remember that the measure of your interior angle and exterior angle are supplementary with each other. So if you added 94 and 96, so you have here 180 degrees. As per your activity this day, so just answer the let's practice A of number 7 and 9. Found on the page 165 of your textbook, third quarter. Then of course, remember that you must have your answer and write it on one sheet of paper. So please have your solution in this. And then of course, you can use the link given by your teacher found in the YouTube channel, okay? So if you do have questions, please do not hesitate to ask your teacher regarding the activity. At the end, so let me discuss your performance tasks for the next week. So we have here a group of businessmen is planning to build an amusement park, and they want the roller coaster to be more exciting and safer as well. So I know that you already know what is a roller coaster, and I think you already ride in it. So they have decided to meet with different designers so that they can choose, then hire the one with the best design, okay? Your goal, so to look at the roller coasters of different amusement parks and make them as the basis for creating a much better roller coaster design. Then what is your role? Your role is you are a roller coaster designer who wants to be hired and present your roller coaster design proposal to the businessman. Then who are the audience? So the target audience is the group of businessmen who will hire you as a roller coaster designer. Then what will be the situation? You need to create and propose a roller coaster design that will convince the group of businessmen to hire you as their designer. So the product, the roller coaster design proposal to be presented to the group of businessmen. Then what will be the standards? So content, accuracy, and creativity. So like what I've told you, this performance task will be discussed again next week. Okay? I'm just going to introduce it to you. Have here the criteria, the descriptive rating, and the numerical rating. So the design is completely accurate, precise, well drafted, and logically presented. So outstanding in the numerical rating is 50. Design is generally accurate, precise, well drafted, and logically presented. Minor inaccuracies do but not affect the overall design. So we have good and 45 as your numerical rating. Design is generally accurate. Minor inaccuracies somehow affect the parts of the design. So satisfactory with a numerical rating of 40. Then design contains major inaccuracies at all. So that needs improvement with a numerical rating of 30. Then of course, the submission of your outputs or your performance task for week 5 and 7 is on March 8, 2022. So that would be all for today. Again, if you do have questions, please do not hesitate to ask your teachers. So God bless and stay safe.